Thanks for joining us. My name is Ray. I'm the CTO and co-founder of Oasis Labs. And today I'd like to tell you about some of the work that we're doing to address some of the fundamental problems in data privacy and technology to address security and privacy of data on the internet. So I think it's undeniable that data is fundamental to our daily lives. It's the underpinning of many different companies. And ultimately, what it means is that more and more our lives are shaped by how data is processed. But one fundamental question that I think we need to ask ourselves is whether or not we're using this data responsibly. And our community believes that decentralization and blockchains have a big role to play to help us do this responsibly in a better way. And we're trying to address a number of pretty fundamental problems that exist today. The first of which is data breaches are just happening left and right. I mean, there's a scary graph here that we're going to show that shows the scale of data breaches growing over time. There's an equally scary graph where it's not just large companies being hit, obviously. It's up and to the right, the number of data breaches that are happening on a yearly basis as well. And ultimately, what this shows us is that the current way in which we're building services and applications is unsustainable. Compounded by the fact that data security is a big problem today, one of the things that we're noticing as well is that users are increasingly feeling like they're losing control over their data. A startling statistic from a recent survey shows that 63% of users don't trust Facebook at all or not much. And what this means is that there's an increasing feeling that users are no longer in custody and in control of the data that they provide to these services. What that means is that it culminates in a world where regulation is becoming increasingly a reality. So what we're seeing is that data privacy laws are being proposed all over the US, certainly around the world as well, and we're starting to see that the tides are starting to change. It's an ample time and a unique time to try to address the way in which we're processing data. Now, it's not meant to just be scary statistics here. I think this represents a really unique opportunity. What this shows us is that we are currently limited by the technologies that we currently have. People say that the biggest obstacle to using advanced data analysis isn't skill-based or technology, it's just plain old access to data. What we're seeing is that data is increasingly siloed and underutilized. If you think about the average healthcare provider uses 16 different EMR systems. If you think about the average Fortune 500 company, they use hundreds of different information systems, different cloud systems. And if you are part of a company yourself, you'll know that your data is split across many different services. And just imagine the types of things that you'd be able to do if you could pool that data together to do advanced analytics across all the different providers that you use. Everything from your productivity software to your sales software to your developer software. So our community is driven by a mission to build a platform to empower developers to build applications that help users retain data privacy and security, both at rest, in transit, and in use. So in this talk today, we'll cover some of the fundamental technologies around the Oasis platform and how we achieve that, a couple of enterprise applications where we believe that this technology will be really useful in the short term, as well as give you a taste of what the tools and features of the platform looks like and what it's like to develop on the system. So the fundamental challenges on the technological side that we have to address are threefold. The first of which is increasingly we have to treat our infrastructure, including your cloud infrastructure, as potentially untrusted. And it's not necessarily mean that the cloud itself is untrustworthy, but given the sophistication of hackers today, you have to design your systems as if they're going to be hacked, as if your underlying servers could potentially be malicious at any given time. The second fundamental issue is that today applications just operate over raw data. And what that means is that trivially, if you can compromise the application itself, you typically have an attack vector that allows you to do a pretty wide-scale data breach and data compromise. And the third issue is that the outputs themselves often unintentionally and undesirably have data leakage themselves. So as a platform, we're trying to address these on all layers of the stack. At the infrastructure level, we're building a scalable smart contract platform that's unique in a number of different ways. The first of which is that it's meant to scale to cloud workloads to be able to support more sophisticated applications than we typically see in blockchains today, and do it in a way where we can protect the confidentiality of the data. So we have this abstraction that is a privacy-preserving smart contract where we can keep data inside the smart contract secret as well as inputs and outputs to the contract secret. And lastly, we have a suite of tools to enable developers to more easily build privacy-preserving analytics and machine learning on top of this data. So at the integrity level, smart contracts give us the ability to emulate a trusted third party for transaction execution between users. So what this means is that the results are guaranteed to be correct under a much stronger threat model. It doesn't require trust in any individual centralized party, and it gives developers the ability to read and write data to a distributed ledger. And this distributed ledger now provides a nice, immutable, auditable history where we can actually track all of the interactions with the application over time. So we use this for writing to logs, we use this for high availability and integrity, and we use this as a mechanism for security auditors to come back afterwards to check how that data is being processed over time. Now, this in itself does not provide privacy. When it comes to data confidentiality, there are a suite of tools that we're working on largely in the area of what's called secure computing. And fundamentally what that means is that given a particular program and given some amount of encrypted data, we'd like to be able to compute over that encrypted data and provide you with results in a way that we can prove to be correct. There's a number of different ways that we can achieve this. There are hardware-based mechanisms like secure enclaves. There's also cryptographic mechanisms and software-based mechanisms. And as a platform, we're trying to build a collection of tools to help application developers choose the secure computing method that makes most sense for their application. We're also working on a set of tools for verification and model checking. So the idea here is that given an arbitrary program, we want to be able to check that this program satisfies a particular policy. This program and policy might be arbitrary. So you want to be able to say arbitrary things about how data can and cannot be used by this program. We want to use rigorous and sound formal methods, techniques to be able to check that the program actually satisfies certain properties. And we can do this with program rewriting to be able to transform an untrusted program into one that can safely safeguard the data itself. So one example of a guardrail that we're building is that around differential privacy. So differential privacy is a really powerful policy that you can specify on an algorithm like a machine learning algorithm or an analytics algorithm. And this slide tries to give a high-level informal definition of what that means. Of course, there's many papers I'd be happy to point you to if you'd be curious about the mathematics behind this. But at a high level, differential privacy basically means that if I'm trying to do some kind of query on some kind of database, and let's suppose that there's a database 1 with Joe's data and database 2 without Joe's data, what that means is that if I have a program that satisfies differential privacy, if I submit that query to both databases, the result I can prove to be approximately correct to the point where it's impossible to tell whether or not Joe's data is in there or not. And what you get here is a result and an outcome that is the same with or without Joe's data. It's from a mathematical perspective, one of the strongest definitions of privacy. Because in this case, you get the result, but it doesn't mean that this result leaks anything about Joe's individual record at all. And so we need to be able to prove this mathematically for every user and every potential database. And this provides a strong guarantee for individuals while enabling analytics and machine learning over sensitive data. So at a high level, these are the fundamental nuggets that enable us to build a decentralized platform for processing data analytics and machine learning. The blockchain helps us enable high integrity. It enables a decentralized orchestration layer with strong correctness guarantees, strong notions of transparency, and an ability for security auditors to audit what's going on. We have a data confidentiality layer that enables us to reduce the amount of trust necessary to process the data. And we have a bunch of tools around providing guardrails to eliminate the need for a data provider to necessarily trust the data consumer to comply with a particular policy. The tools will do that automatically themselves. So one manifestation of this is an application which we call secure functions, which we believe to be immediately useful for some of our enterprise partners today. So in this particular example, today when you deploy functions, if you're familiar with cloud functions, it's effectively a way for a developer to propose a piece of code in an application to be running on the cloud somewhere. And today, when a developer pushes code and configurations to the cloud, what happens is that if an attacker is able to compromise a node on that cloud, they ultimately end up being able to control that logic. And what you'll see is that what that means is the attacker, if they're able to compromise the cloud, can do things like distribute malware, they can send you fake pages, they can start to steal data, and that turns out to be a pretty horrible security result. In our system, we're running blockchains across multiple different clouds and multiple different providers. It can not just be across clouds, but also span hybrid deployments across clouds as well as on-premise machines. And by running a consensus protocol across these different clouds, what that means is that even if an attacker is able to compromise one of these deployments, the consensus protocol can check and verify that the result is or is not consistent or correct with what it should be. And what that means then is ultimately the mobile application, we can detect when that happens and block malicious behavior. So what's great about this is that it enables existing developers, existing cloud developers, to deploy their existing applications in a model that makes sense to them, that's intuitive to them, deploy applications that they already know that they need today, and do it in a way such that it's completely transparent to the user. To the user, they're just using any old application like they would on their mobile device. So one example of this where we found a lot of resonance is in a domain which we're calling secure command and control. One of the things that's really fascinating about the cloud is that it's increasingly being used as an orchestration layer for many different devices. So you'll start to see that devices themselves use the cloud to handle upgrades, to receive commands. Your mobile devices do this. There's tens of billions of IoT devices that are listening for commands on the cloud. And what that means is that if we can compromise that cloud controller, it has drastic amplifying effects of how that malware can be spread across devices on the internet. And one of the areas where we're applying secure functions is to be able to create a high integrity version of that cloud controller, such that an attacker who is able to compromise one instance or one cloud deployment of that cloud controller doesn't necessarily have the ability to send reformat commands or malicious upgrades to devices. So in this particular case, similarly, an attacker needs to be able to compromise at least 2 clouds out of 3, if that's your deployment, to be able to modify and alter the application. And in this case, we can provide a much stronger integrity guarantee of the application to end devices. So for the Oasis solution here, our goal here is to provide much stronger notions of action integrity. A pre-configured smart contract can execute in a distributed network, and we can guarantee that these actions are only taken if consensus is agreed upon. Even if a subset of nodes are compromised, incorrect actions, we can guarantee that they're never taken. We have a strong immutable record of how these actions are being played over the network, and we can use this as a way to provide an auditing mechanism for folks that want to make sure that their applications are acting with integrity. And we also have a confidentiality layer to make sure that telemetry or commands or any kind of private user data that's being processed by the system can be done in a secure enclave. Another area where we're applying some of this technology is around confidential data analytics. And if you think about a typical system today, requires that you place trust in a centralized third party in order to do things like analytics. And that gives them an immense amount of power to be able to use that data in a variety of different ways. In this particular case, we want to store data from every device in a secure, decentralized database. And every data set in this case has its own access policy provided by the data owner. Now, when third-party developers want to send data queries to a secure analytics sandbox, we can check that this query is checked against the policy and computed in a secure sandbox. And the results of this query are provided to a third-party developer without exposing individual data records. So third-party developers can create and share outputs to drive better patient outcomes if this is used in a healthcare setting, but being done in a way that can preserve the privacy of the individual data records. How that works on the technology level is that data providers upload their encrypted data and their policies attached to that data to our platform. Our platform can accept various different access requests or programs to process over that data. So this might be, for example, a request to train a neural network to predict a disease. The platform itself will automatically check that this program satisfies a particular policy, for example, differential privacy, as I described earlier. If the policy is satisfied, we can execute that in a secure fashion. And ultimately, the data access is logged to an immutable ledger so that we can track over time how the data is being used. And we can show that the results on the other end, when they're sent back to the original requester, are done in a privacy-preserving fashion. So compared to traditional solutions, sharing data previously was very difficult, because if I wanted to partner with a particular a partner enterprise to work together on some analytics, traditionally I would have to sign some kind of legal agreement and actually just share the raw data and trust that it's being used in a particular fashion. On the Oasis network, that data is always encrypted, and we can use privacy guarantees to prevent data leakage and ensure through smart contracts that the only thing happening to that data is the programs that I have previously allowed in my policy. Traditionally, access control policies are a challenge because it requires the provider to rely on manual processes to make sure that the data is being used properly. In this case, our platform does that automatically and enforced through our platform. Previously, there's very little visibility. If I'm partnering with somebody, once that data exits my domain and enters someone else's domain, it's really challenging to see what's happening to that data over time. And in our system, on our platform, it's all that data access is fully visible to the person providing the data in an auditable log on the blockchain. And previously, there was no mechanism for a comprehensive view of the patient. Typically, every system and every healthcare provider has their own EMR system. They have a partial view given what people have shared to them. This enables a decentralized platform for people to collaborate and have a holistic view of what's going on. So we have a demo of this application that you can check out. It enables users to be able to upload their data and share it with partners in just a few clicks. You can assign policies to each data set, like who can view it, for how long, what applications can use it. You can run analytics on data while retaining that confidentiality and security. And you can quickly search for data in a privacy-preserving fashion. One of the ways that we have been exploring the power of this platform is an application called Kara, which we've been working on with our partners at Stanford Healthcare, as well as UC Berkeley and HEH Zurich. And it tries to solve this problem of siloed medical data by incentivizing doctors and patients to share data together to improve medical research. So a couple of screenshots of what that looks like is patients and doctors can quickly upload and import their data into the Kara application. The Kara application automatically processes that data and stores it on the Oasis platform in a manner as I described earlier. Kara can automatically protect user privacy by using privacy-preserving smart contracts on the Oasis platform. And patients can now choose when they can share their data and give custody back to the patients on how that data can be used, enabling them to share their data with individual medical researchers to use that data while still protecting user privacy. So the workflow is very similar to what I was describing earlier. Patients upload that data with incentives, automatically processing that data on our platform using privacy-preserving smart contracts. It shows a very intuitive web UI so that users or patients themselves don't need to be familiar with blockchain technology. And researchers can access that data using programming models that they're already used to by sending queries and training machine learning models and receiving results back. Now, that's just a handful of different applications that I wanted to show you today. There are a number of different things that we imagine this platform will enable. So we have a number of different developer tools to help you build the next set of applications that we think will protect data privacy and security. And I encourage you to take a look and start with our dashboard. Our dashboard is a product that we launched recently in the last couple of weeks that gives developers an easy-to-use, intuitive interface to manage all your contracts, to take a look and to easily deploy public contracts that we've already written, or to manage the contracts that you're writing. It has a web-based wallet that streamlines the funding process so that users themselves don't need to manage their own MetaMask wallet. Just makes it kind of transparent and easy for users to use. And I would encourage you to check this out today at dashboard.oasiscloud.io. We have a number of different tools that are accessible through our documentation and through the dashboard, including a privacy SDK to build confidential smart contracts. We currently have support for both Solidity and Rust. Rust giving you the ability to use a wide ecosystem of different libraries and dependencies to build more complex applications. It's a pretty general purpose programming language. We're backwards compatible with Ethereum, so if you want to get started easily, you have Solidity support, and we already support most of the major tooling workflows for Ethereum application developers. And we have a number of different tools like Contract Kit to make it easy to get started with all of your dependencies right away. So if you have any questions, feel free to check us out at oasislabs.com or send me an email. I'll be around this conference to chat. All right, thank you very much.